Hello everyone, thanks for watching this presentation. My name is Miller, Application Engineer from CCAT Technology. Today, I would like to present a SOLIDWORKS multi-product demonstration to show you how our products can benefit your daily design work. SOLIDWORKS products provide an intuitive solution for every stage of your design. You can start your mechanical design with the CAD module. In the CAD module, you could easily create the 3D models for both parts and assemblies. And of course, there are 2D drawings as well. After finishing the 3D models, SOLIDWORKS simulation packages will allow you to carry out design studies instantly, like FEA analysis, CFD calculation, as well as plastic injection simulation. After design and simulation, you may use SOLIDWORKS inspection tools to help you efficiently generate your inspection report, thus improve the product quality. Additionally, SOLIDWORKS Composer provides great feature for you to communicate your design ideas easily to the end users. And of course, we do have the centralized data management system to assist you throughout this entire process. Now, I'm going to use this live demonstration to explain how these modules work and what benefits they come along with. In this demo, I use an iPhone case as an example. The demo will start with the CAD module, which will cover part design, part drawing, assembly design and drawings, and then we'll be looking at the simulation modules for a simple stress analysis and a plastic injection study. After that, next module will be about SOLIDWORKS inspection for QC report generation, followed by SOLIDWORKS Composer, which is used to create technical communication contents. First thing first, let's take a look at how we can design this piece of back cover of the phone case using SOLIDWORKS. SOLIDWORKS allow us to directly start our design sketch on any of the three primary reference planes. For this part, let's start it on the front plane by doing a rectangle at the center, and then we extrude it out. After extruding, we quickly apply a chamfer feature to the outer edges by keying in the size and angle dimensions. You will notice that the chamfer feature could also be created by simply applying it to the face that contains the edges, instead of selecting them individually. Then let's go back to the frontal face and create the next feature. Simply draw another rectangle and extrude cut into a step. This is where the foam body will be constrained. Similarly, we could use the Fillet Expert feature to create the round corner fillet to different group of edges by just a simple mouse click. Come back to the frontal face again. We could make use of the existing geometry as a reference and create the next sketch immediately. Simply offset the inner edge of the newly created face and cut it through. Another great thing in SOLIDWORKS is that it allows us to easily reuse the sketches from previous design. For example, the profiles of the cutting features on the boundary. We could save them and insert them beforehand. And then, when the model is done, we just need to cut out those sketches and create an extra cut from there. You will notice that the cutting profile is not necessary to be a close profile. This flexibility in SOLIDWORKS does save us plenty of valuable design time. We could also apply the same method to create the cutting holes for the buttons on the side as well. In extrude cut option, up to next and through all conditions will really save us from measuring the parts thickness and making the cutting an easy task. Now the part is almost finished. As the back of is assembled together with the copper spacer, the last step is to subtract out the groove on the back cover. We could directly insert this 3D parts into the space and perform a subtract boolean operation. After that, delete the unused body, and then we are done. After creating the model, of course, last but not least, we could apply material to the parts. SOLIDWORKS material library contains various material from metal to plastic and etc. All the material properties are also defined or could be customized easily. Let us use polyethylene for this part. And after applying the material, we can also define a more realistic plastic look to the model using the appearance library. Just now we have demonstrated how to create such a back cover parts in 3D using SOLIDWORKS. As we all have seen, SOLIDWORKS implements a simple and intuitive workflow that is easy to learn and use. Very friendly user interface with lots of interactive design. With these features, we could achieve our 3D design accurately, efficiently. After creating the 3D model, the next step is to generate the 2D production drawing. In SOLIDWORKS, creating 2D drawings are even simpler than its 3D model. Let's have a look. To create 2D drawing, we just need to simply select the drawing views from the view palette and drag it to the graphic area. Projection views would also be automatically called out after dropping the previous drawing view. Since all the dimensions and tolerances are already defined in the 3D stage, inserting them into the 2D drawing is just a simple click. Now, as you can see, this 2D drawing view is completed within less than 30 seconds. So to sum up what we have seen, SOLIDWORKS enables the users to create detailed quality 2D production drawings with automatic view and dimension placement. This will help the users to avoid drawing errors and save their drafting time. Well, the part and its drawing has been created easily as shown just now. The next step would be to put the parts together to form an assembly. SOLIDWORKS also provides great features in the assembly design stage. Let's have a look how it works. As you can see, the back power part is still missing in the assembly. What I need to do is just insert this component into the graphic area. To precisely place the parts, we need to use the make function to fully constrain the new part with the existing model. Quick Make feature allows me to directly select the corresponding faces, and the available make options will be just pop up and applied. Now the assembly is completed, and we could create some exported views of the assembly for better instruction. In SOLIDWORKS, we could easily create an exported view by dragging the parts or assemblies to the desired location. It can be either linearly or radially dragged in the 3D space. After creating the exploded configuration, the explosion process could even be animated and saved as a short video. Okay, once the assembly is finished, let's create the 2D production drawing together. Same as the part drawing, we could also call out the isometric view and projection views from the view palette and drop them onto the drawing sheet. Also, the exploded state of the isometric view could also be activated by a single click. Next, we can insert the bill of materials in the drawing to include the production information like part number and description. Additionally, the balloon pointing to individual parts can also be inserted in one shot as well. Just now we have gone through the process of creating case assembly and its 2D production drawing. For the assembly, SOLIDWORKS allow us to simply position each component with its innovative productivity tools. And for the drawings, SOLIDWORKS is following a consistent workflow that can automatically insert the bill of materials and item balloons together with their comprehensive assembly views. At this point, we already created dozens of documents like parts and assembly together with their drawings, although our model is quite simple. This situation will get more complicated as the number of files increases in a big project. Managing those design data will be soon challenging. In SOLIDWORKS, as mentioned at the beginning, it provides an intuitive solution for every stage of your design. For data management, SOLIDWORKS Enterprise PDM makes the whole workflow a simple task. SOLIDWORKS EPDM lets you safely manage all of your data in a centralized, secure vault so only authorized users can view or make modifications. Let us go back to the assembly drawing and have a look at how EPDM streamlines our design workflow. The moment I opened the drawing, a dialog box popped up asking me whether I would like to check out the file. This is because the whole assembly is stored in the server. If I do not check it out, the drawing will be just open as read-only. The same idea applies to the assembly 3D model as well. When I try opening it, the message says that the assembly will also be read-only without checking out. So to make the modification applicable to the document, I can firstly check it out in the built-in EPDM interface. And you will notice that another dialog box pop up to remind me to check all the documents that are referencing or referenced by this file. This prompt would definitely help me avoid a lot of human mistakes. Let's continue to clean up the drawings just now I have missed out. We just input the top view and some key reference dimensions. Since we have checked out the drawing and assembly, these two documents will be marked as checkout by me if you go back to the Windows Explorer. As you can see from here, when those files are checked out, other people will not be able to edit these documents, and therefore, all the conflicts will be avoided in the whole team. Well, after I finish all the changes, I can easily check them in, and again, the system will remind me that a new version will be created and all the references will be listed as well. We can also put some comments during check-in so other people will be very clear on the difference between each version. Other than the version revision control, EPDM also provides an integrated interface with Windows Explorer for easy adoption. We can also easily check the status of the documents, the bill of materials, and the file references even without SOLIDWORKS. As we can see, Enterprise PDM system thus has a seamless integration with SOLIDWORKS, help us efficiently manage our data across the entire organization without any mistakes, and let us purely focus on our design. So far, we have shown how to do 3D part and assembly designs plus their 2D production drawings. Using the same method, we can also quickly finish the completed case assembly with the iPhone model inserted. The final model just looked like the picture there. Now we have finished the design stage, but SOLIDWORKS does not stop here. It provides an intuitive solution for every stage of your design. The next stage, I would like to start with the simulation modules first. As we design this case assembly to be fixed by 4 screws at the 4 corners, you may concern if this fixture is strong enough. Nowadays, instead of using bolts and nuts, lots of plastic products are assembled using clips. What if someone does not see the screws and try to open it by force? Will our design be able to stand these forces? To answer that, let's run a simple stress analysis. Look at the assembly model. Imagine the person is holding the assembly using his index fingers and middle fingers from both hands and trying to open the case from the bottom using his 2 thumbs. Let's create a static stress analysis on half of the assembly here. There are a few steps to go through to set up the study. Step 1 is to define the material. As mentioned earlier on, SOLIDWORKS material library serves a detailed material database, Young's modulus, use strength, density, etc. All these properties could be found easily in the library. Step 2 is to define the fixture. For the study to run, user need to clearly define where the part or the assembly is mounted or fixed. In SOLIDWORKS, different types of fixtures are available to constrain the degree of freedom of the model, like the fixed geometry, roller or slider, and or even hinges. The next step is to apply the loading. In this case, I just simply apply a uniform 10 Newton force acting at the bottom face normal to the frontal plane. This is to simulate the force exerted by the person's thumb. There are also other types of loading available in SOLIDWORKS like pressure, gravity, barren loading, and etc. After applying the loading, we can quickly generate the mesh to this model. Creating mesh is also a very simple task in SOLIDWORKS. We could easily use the slider to control the level of mesh, or specifically define the mesh size as we desire. Finally, let's run the study. The result will be quickly calculated and shown in the screen. We could directly see the plot of stress distribution, displacement, strain, safety factor. Also, the result could also be presented in the different parameters like Bomister stress or principal stress. Displacement could also be shown with the maximum or minimum values. This result provides a clear and direct feedback on whether the model is strong enough. For example, we could see that the maximum displacement of the back cover is 2.2 mm under this 10 Newton force. As we all see, SOLIDWORKS simulation is a very easy to use tool that comes with an intuitive workflow. Simulation could be quickly set up in the CAD integrated interface, which will make the analysis time much more shortened. Talking about plastic part, another common concern is about the plastic injection process. I do receive many feedback from people who are designing plastic parts. Lots of designers would like to have a quick preliminary injection simulation before they send the CAD files to the contractors. To achieve that, the answer is very simple. In SOLIDWORKS, the plastic simulation module allows us to have a quick evaluation of the manufacturabilities with our CAD model. Similar like the FVA module, we could follow a consistent workflow to quickly set up a plastic simulation study. In this case, we firstly generate the mesh for this part. In SOLIDWORKS, there are two types of mesh available. SOLIDWORKS can provide solid tetrahedral mesh and prismatic shell mesh. The next step is to define the plastic material. Different from the default material library in the CAD module, SOLIDWORKS plastic material database covers a huge range of plastic material. Similarly, it comes with a vast database of the mold material as well. Either it's predefined or user-defined materials could be both accessed within a just few mouse clicks. After the material, we can now define the filling process setting as well. Not only that, SOLIDWORKS plastic also comes with a big machine database for you to choose. Various models of machines from different vendors could be easily accessed and configured into one interface. And the step 4 is to define the injection gate location. In plastics, adding injection location is just a few clicks. And after that, we are ready to run the study. While the study is running, we could see a direct display of the filling process on the screen. This provides a deep insight into the actual filling operation to the designer. After running it, we could play a slow motion of the filling process and have a detailed view. Not only filling time, pressures and temperatures at the end of the filling, or even the wall lines and air traps could also be directly displayed on the 3D model. After looking at this demo, we could definitely see that SOLIDWORKS plastics allow us to carry out a quick evaluation on the part manufacturability, help us to eliminate costly mold rework, improve part quality, and accelerate time to the market. As designers, coming out with good design idea is not the only job. We also need to make sure the production manufacturing information could be smoothly and accurately passed down to the downstream fabrication team and the quality control team. In the old days, creating inspection report was always a challenging task. However, with SOLIDWORKS inspection, this task just became a breeze. When the inspection module is activated, we can directly start an inspection project in the 2D drawing. This inspection module is able to cross-reference the custom properties for the drawing files directly, like the part number, part name, and revision number. Additionally, user can also easily define the vendor information and custom inspection process information. The second step is to define the extraction setting, as not all of the dimensions or tolerances will be inspected. For example, the basic and reference dimension, extraction criteria like hole cutout or surface finish could be simply checked or unchecked. Lastly, after defining the default precision setting, we are good to go for the balloon process. As you can see, after clicking the OK button, all the dimensions and tolerances in the drawing sheet that are going to be inspected will be automatically ballooned in a clockwise sequence. Clicking on a particular balloon, the detailed inspection information will be displayed on the left. SOLIDWORKS inspection feature does not stop at creating balloon drawings. We could also export the balloon result as an Excel sheet for the final inspection process. Choosing a proper template and click the export button, a first article inspection report will be pop up. Inspectors in the QC department could directly key in the measurement result in the spreadsheet, and the result will be automatically highlighted in green or red color, indicating a pass or fail condition. The auto coloring function will definitely save us plenty of time on the result checking. As we all see, SOLIDWORKS inspection can help us automate the inspection report generation procedure, which will reduce the documentation time dramatically. It also eliminates the input error introduced by human, improve the part quality, and shorten the time to the market. To deliver a good product to end customer, an accurate inspection report is not enough. In fact, with the help from SOLIDWORKS, we could create a great product image by delivering clear and impressive technical documents. That is where SOLIDWORKS Composer comes into the picture. Here is the sample assembly instruction I created for the iPhone case. The models are directly imported from the 3D SOLIDWORKS assembly file. No extra conversion is needed. The complete assembly structure will be maintained in the Composer as well. After inserting the model into SOLIDWORKS Composer, we can create different visual effects like the colors, backgrounds, captions, views, and exported views with bill of materials, hyperlinks, or even animations. This file can be saved as multiple formats. Depends on customers' requirements. You have the option to export as high-resolution images, vector images, videos, 3D PDF documents, or even HTML format for online presentation. Furthermore, SOLIDWORKS Composer support real-time design changes update from the CAD models. Instead of rework on the visual effects, Composer is able to update the CAD geometry directly without losing any references. It means that the documentation team can start creating the technical instruction with a preliminary CAD model without waiting for the designer to finalize their design. The documentation work becomes a parallel process with the design work and will complete much earlier than the old days. Based on what we have discussed, we may say that SOLIDWORKS Composer allows us to easily create graphical content directly from our CAD data. It can instantly update the document if the design changes. The interactive content will bring more value to your product by delivering highly accurate and impressive technical documentations. To summarize what we have gone through here, I have shown you how you could easily use 3D SOLIDWORKS to create parts and assembly and their 2D drawings with the CAD module. After finishing the 3D model, we use SOLIDWORKS simulation tools to carry out two design studies instantly, namely the stress analysis as well as the plastic injection simulation. After design and simulation, we use SOLIDWORKS inspection to show you how it helps you efficiently generate the inspection report and improve the product quality. And then, we explored how SOLIDWORKS Composer can help you communicate your design idea effectively to the end users. And most importantly, SOLIDWORKS EPDM works as a centralized secure system, help us to smoothly manage all the product data management effortlessly. Our demonstration have proven that SOLIDWORKS products provide an intuitive solution for every stage of your design. Make great design happen has never been easier with SOLIDWORKS solutions. Thank you.